Welcome to this explainer. If you've ever looked at the sheer, overwhelming volume of modern data stores and felt like you were staring at a chaotic bowl of alphabet soup, well, you're definitely not alone. Today, we're mapping out the data architect's journey into big data solutions. We're going to organize this massive landscape so you can make strategic, highly effective storage choices. So, let's start by confronting a real foundational challenge. How do you actually choose the right data store? It sounds simple, right? But with the constantly growing mountain of storage options out there in the modern tech ecosystem, logically aligning your specific data characteristics with the perfect technology is honestly a meticulous science. It's definitely not a guessing game. Here is exactly how we'll break down the ecosystem today. First, the big data toolbox. Second, mapping models to data stores. Third, moving code to data. Fourth, polyglot data solutions. And finally, aligning with business goals. All right, let's dive right into section 1, the big data toolbox. You know, every successful data architect needs a really deep understanding of their materials. We have core data models forming the absolute bedrock of big data. You've got key value for raw, blistering speed, document for storing flexible objects like JSON files, column family for just massive, massive scale, graph for tracking heavily interconnected relationships, and HDFS for highly distributed file storage. Think of these as highly specialized tools in your belt. Just like you literally wouldn't use a hammer to drive a screw, you absolutely shouldn't use a document store to house highly complex graph data. Moving right along to section 2, mapping models to data stores. Now this is where things get really interesting. Notice how we can finally bring some order to the chaos by mapping these distinct technologies directly to the exact data model they were built to serve. Need high-speed key-value lookups? Boom, you're looking at Redis or DynamoDB. Dealing with massive, wide column scale? That's where heavyweights like Cassandra come into play, which, fun fact, was originally developed at Facebook just to handle their inbox search. Then you have MongoDB perfectly representing flexible document stores, while Neo4j is your go-to for complex graph relationships, things like fraud rings or social networks. And for broader ecosystem SQL interactions, there's Hive. By looking at it this way, we completely transform a random list of buzzwords into a precise, highly navigable map. Next up, section 3, moving code to data. Historically, we consistently moved massive volumes of data across our networks to reach our central processing code. But in the era of big data, moving petabytes of information just creates an absolute nightmare of a network bottleneck. It's literally like trying to mail an entire commercial kitchen to a chef just so they can cook a single meal. It makes no sense. The modern strategy completely reverses this old paradigm. Now, we move the lightweight processing code, which is often just a few kilobytes, directly to where that massive mountain of data already lives. By sending the chef to the kitchen, so to speak, we eliminate those bottlenecks and process vast quantities of information at just incredible speeds. Which naturally leads us to section 4, polyglot data solutions. Here's the secret. In the real world, you absolutely do not have to pick just one single data store for your entire architecture. Enter the polyglot data store solution. Basically, this is an architecture that speaks multiple data languages fluently. Just imagine a modern e-commerce platform. It might use a document store for its really flexible product catalog, a key value store for its lightning-fast shopping cart cache, and a graph database to power a super complex recommendation engine. All of these combine perfectly within the exact same enterprise application, ensuring each tool plays exactly to its unique strengths. Finally, we arrive at section 5, aligning with business goals. Because at the end of the day, the architect's journey is a continuous, active workflow. First, you have to deeply analyze your data characteristics. Next, you select the correct data store, or, as we just discussed, a polyglot combination of data stores from that newly organized toolbox. But the final, and honestly the most crucial step by far, is ensuring that every single technical choice explicitly supports a core business goal. This workflow is what ensures our architecture isn't just functionally sound, but practically, strategically valuable. Ultimately, architecture isn't just about the technology at all. It's entirely about business alignment. Think about it. All your incredible technical mastery of MongoDB, Neo4j, or Cassandra, none of it matters if those polyglot solutions and processing strategies aren't actively driving the business forward. The technology is simply the vehicle. The business goal is always the ultimate destination. So, this brings us to a final thought for this explainer. The next time you face a truly complex data challenge, don't just ask, what technology should we use? Instead, ask yourself, What specific business goal are we actually trying to achieve here? Master your data characteristics, absolutely. Map your tools, for sure. But always, always let the goal dictate the build. So what business goal is going to dictate your very next big data architectural choice?